Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here in this question, we are given that you walk from your house to library and then from library to park. So we have to calculate the total distance traveled and the displacement. Now we're going to solve the A part first. Now distance, we know it is the total length of the trip. So this is the positive x direction. Now first you walked from house to library, so the distance would be 0.75 mile plus 0.60 mile. So we have reached here. Now from library to the park, so you have to add this distance also, that is 0.60 mile. So the total distance traveled would be 1.95 mile. So this is the answer for the A part. Now next we can solve the B part, where we have to calculate the displacement. Now displacement is the change in position. This was your initial position and this is the final position. So this time the displacement, this would be equals to the final position minus the initial position. Final position we have 0.75 mile, and initially this is at origin, this is x equals to 0, so this would be 0 minus 0 mile, so that would be 0.75 mile. So this would be the answer for the B part. Now here in this question we are given that two tennis players, as you can see in this figure, walk to the net, this is the net, to congratulate each other. Now there are two parts in this question that we need to solve. In the A part, we have to find the distance traveled and the displacement of player A. So this is player A. Now before this, let me explain that this is our positive x direction. This is a coordinate system. So this direction would be positive and this direction would be negative. Now we can solve the A part. Now distance would be equals to the total length of the trip. So total length for player A is 5 meter. Now displacement is the change in position delta x. This is xf minus xi. Now the final position for player A is this, where x equals to 5 here, and here we can take it to be origin, x equals to 0. So this is the final position, this is the initial position. So displacement would be 5 minus 0, which is equals to 5 meter. So this is the answer for the A part. Now next we have to solve the B part. Now in the B part, we have to repeat the problem for player B. So the distance for player B would be 2 meter. Clearly it is visible in the figure. Now displacement, initially we have taken that this is our origin, x equals to 0. So xi, that is the initial position, this would be 7 meter. So xi we have 7 meter, and the final position here, this is 5 meter. So xf we have 5 meter. So displacement is xf minus xi. So 5 meter minus 7 meter. So that would be equals to minus 2 meter. So this would be the answer for the B part. Now here in this question we are given that jogger runs on this track, as you can see in this figure, and we have to neglect this curvature for solving the problem. Now in the A part, we have to find the distance traveled and the displacement in running from point A to point B. So this is point A and this is point B. Now before solving, we'll define the coordinate system. So this direction we have taken it to be positive, x-axis. So this direction would be positive and this direction would be negative. Now we can solve the A part, case A. Now distance traveled, distance is the total length of the trip. So it started from point A. So this, then this, and then this. So this distance would be 15 meter, because this total distance is 30 meters. So half of this would be 15 meter. So 15 meter plus this is 100 meter. Then from here to here is 15. So plus 15. So this would be 130 meter. So this is the total distance traveled. Now the displacement delta x, xf minus xi. This is the way we find the displacement. Now this is the initial position for the jogger, and this is the final position. So we can write this is xf and this is xi. So xf we have 100 meter, and xi we can take this to be as origin, x equals to 0 here. So 100 minus 0, so this would be 100 meter. So this is the answer for the A part. Now next we can solve the B part. Now in the B part, we have to find the distance and the displacement for the complete circuit of the track. So it started from point A, then again it comes back to point A. So the distance would be the total length of the trip. So this would be 15, then this is 100, then this is 30, and then this is 100, and then again 15. So we can write 15 plus 100 plus 30 plus 100 and then plus 15. So this would be 260 meter. Now we can solve for displacement. So delta x is xf minus xi. Now this is the initial position and this is the final position. So xi is also same, xf is also same, that is 0 minus 0. So this would be 0 meter. Now here in this question we are given that you drive your car in a straight line at 15 meter per second for the first 10 kilometers. Now next 10 kilometers you travel at speed 25 meter per second. Now we have to tell, is the average speed for the entire trip is greater than, less than, or equals to 20 meters per second, and we have to choose that which of the following is the best option. Now at the first look it seems that the average speed is equals to 20 meters per second, but actually that's not true. Now observe carefully. Now for the first 10 kilometers you travel at 15 meters per second, and next 10 kilometers you travel at 25 meters per second. So logically you'll take more time to cover this much of distance, and you'll take less time to cover the next 10 kilometers because your speed is more. Therefore you will be traveling at a lower speed for a greater period of time, and hence the average speed will be less than 20 meters per second. So the correct answer would be that the average speed would be less than 20 meters per second, and the reason is that you spent more time at 15 meter per second than at 25 meters per second. So A option is, this first option is correct, and the answer would be that this is less than 20 meters per second. Now there is important note here. Suppose you drive your car in a straight line at two different speeds, same 15 meters per second and 25 meters per second, but for the same interval of time. Suppose this is now 10 kilometers, now you travel for 10 minutes. This is 10 minutes here, and here also 10 minutes. Now you will be traveling for the same interval of time. For 10 minutes you travel at 15 meters per second, and for the next 10 minutes you travel at 25 meters per second. So this time the average speed would be the mean of these two speed, that is 1/2 25 plus 15, and that would be equals to 20 meter per second, because you travel at different speed but for the same interval of time, 10 minutes and 10 minutes. That is why this time the average speed would be 20 meters per second. Now here in this question we are given that Usain Bolt runs 200 meter in 19.19 seconds. We have to calculate the average speed, and we have to write the answer in meter per second and miles per hour. It's a very simple question. Average speed we know it's distance traveled divided by the elapsed time. So distance we are given it to be 200 meter, and time we have 19.19 seconds. So this would be 10.42 meter per second. Now we have to also write the answer in miles per hour. So here we have to use the concept for unit conversion that we studied earlier. So 10.42 meter per second. Now we know that in 1069 meters we have 1 mile, and in 1 hour we have 3600 seconds. So here we see that this one and this one would cancel, this one and this one would cancel. So this would be equals to 23.32 miles per hour.